Good morning, everybody. We're going to have our physics class this morning, and our topic is the cathode ray tube. The cathode ray tube. So, what's the cathode ray tube? The cathode ray tube is a vacuum tube that contains an electric gun and a fluorescent screen that can be used to display images. It modulates, it accelerates, and deflects electron beams onto the screen to create images. These images can be represented as electric waveforms in terms of your oscilloscope, can be presented as pictures like your television and your computer monitor. I want you to watch this video for better.
A cathode ray tube is the forerunner of the television tube. It is a glass tube from which most of the air has been evacuated. When the two metal plates are connected to a high voltage source, the negatively charged plate, called the cathode, emits an invisible ray. The cathode ray is drawn to the positively charged plate, called the anode, where it passes through a hole and continues traveling to the other end of the tube. When the ray strikes this specially coated surface, the cathode ray produces a strong fluorescence or bright light. When an electric field is applied across the cathode ray tube, the cathode ray is attracted by the plate bearing positive charges. Therefore, a cathode ray must consist of negatively charged particles. We know these negatively charged particles as electrons. A moving charged body behaves like a tiny magnet, and it can interact with an external magnetic field. The electrons are deflected by the magnetic field. As expected, when the direction of the external magnetic field is reversed, the beam of electrons is deflected in the opposite direction. In 1897, J.J. Thomson, an English physicist, determined the charge-to-mass ratio of an electron. He adjusted the electric field so that the electrostatic deflection, theta E, was the same as the magnetic deflection, theta B, and was able to calculate the charge-to-mass ratio of an electron using the following equation, where E is the applied electric field, theta is the angle of deflection, B is the applied magnetic field, and L is the distance traveled by the cathode rays. Thomson determined the charge-to-mass ratio of an electron to be negative 1.76 times 10 to the 8th coulombs per gram.
Okay, so we're going to talk about the cathode ray oscilloscope. And what is the cathode ray oscilloscope? Okay, the cathode ray oscilloscope is an electronic test instrument that is used to obtain waveforms when different input signals are given. Okay, it works on the principle of the cathode ray tube because it contains a cathode ray tube.
Some modifications are made to the cathode ray tube to invent the cathode ray oscilloscope, CRO. The cathode ray oscilloscope is built up of three main parts. The first part, which looks like the cathode ray tube but with a few changes, is named the electron gun. This part produces electrons by the property of thermionic emission. The second part is the deflection system, and it causes the deviation of the electrons from its normal straight line pathway according to the voltage applied to the plates. It consists of the Y plates. They are responsible for deflecting the beam of electrons vertically up and down. The other two plates are named the X plates, and they are responsible for deflecting the beam horizontally left and right across the screen. The voltage on the X plate is controlled by a button on the interface. This button is referred to as the time base. The third main part of the oscilloscope is the fluorescent screen. The screen is plated from inside with a layer of a substance that is sensitive to electrons. It gives a bright spot on the position where the beam of electrons falls on the screen. In this part, we will learn how to draw a label diagram of the CRO. First, you must draw this shape that will indicate the vacuum tube that encloses most of the parts. Starting from the left, the cathode is drawn as a basic cylindrical shape. The heater or the filament with its supply are drawn as a circuit behind the cathode. The hollow tubes are drawn to represent the anodes. Between the cathode and the anode there is a ring. This ring is known as the grid. Now the cathode and the two hollow tube anodes are connected to a high voltage DC supply about 600 volts. The negative is connected to the cathode and the positive to the anodes. Two parallel horizontal plates are drawn to represent the Y plates. Next to these plates are two parallel vertical plates to represent the X plates. And finally, this is the beam of electrons. This will make a flash on the screen. This is how you will draw it in the exam. Now label the parts. All the apparatus are placed in a vacuum tube. Starting from left, the labels are the heater or the filament, the cathode, the grid, the two hollow tube anodes, the high voltage DC supply, and all these parts form the electron gun, the Y plates and the X plates, and these will form the deflection system. The last part is the fluorescent screen. This is how you will draw and label the parts of the cathode ray oscilloscope.
Okay, this is an example on the cathode ray tube, a WAEC question on the cathode ray tube. And if you look at this question, you are asked to identify the components X, Y, and Z. And if you have looked at the video, you'll be able to say that X is your filament or heater, your Y is your anode, and your Z is your plate or deflectors. So this is where we're going to stop on today's class. Thank you for